Hello, welcome to In 5 Minutes. Next concept is the reverse bias PN junction. Now, what do you mean by reverse biasing is the P type which is positive and N type which is negative. P type is connected to the negative terminal of the battery and N type is connected to the positive terminal of the battery. That means we are reverse biasing the PN junction. Now, what will happen because of this? Since you are reverse biasing, P type has positive holes and N type has the electrons. It has positive charge and it has negative charge. So because of this negative at the negative potential of the battery, what it will do is it will attract more number of holes from this part and more number of electrons from this part. So because of this, what will happen is this potential width, potential barrier width or space charge region, which was initially this smaller value, is now been getting wider over here, and here you will have more number of immobile ions. Similarly, here you have more number of immobile holes, because once the electron movement is from N type towards the P type, right? So the electrons will start moving over here, and the region of the potential barrier, which was initially W, is now changed to W1. That is, width increases if we increase the value of the reverse bias voltage. That means negative charge, it will attract all the holes from the P type, and the minority carriers it will try to move, but because of the potential barrier it cannot drag more number of holes from the N type. So as the number of holes are decreasing, here you have large number of negative ions getting generated, so you have increased the electric field. The initial electric field was E, it is shown in the diagram, which is in the same direction. Now because of EA, again you will have the electric field in the same direction. So the net result is the electric field has now a larger value as compared to the equilibrium condition. Larger value as compared to the equilibrium condition, because E bar, which is the electric field at the equilibrium condition, and EA, which is when you are applying a negative voltage, are both in the same direction. So net result is your electric field now increases if you apply a negative bias. Now if you are increasing more, again the width of the potential barrier increases, and it will not allow the movement of free electrons and holes from either side of the PN junction. Now because of the additional positive and negative charges induced in the space charge region, these are the additional positive and negative charges induced in the space charge region, with an increase in the reverse bias voltage, a capacitance is associated because of this in the PN junction when a reverse bias is applied. Now what is the value of this capacitance? The junction capacitance is Cj, which is Cj0. That is the junction capacitance when VR is 0. That is, we are at equilibrium. When we are applying VR as 0, VR as 0 is nothing but equilibrium condition, and when you are applying VR, this value is considered over here, and Bi is the potential barrier voltage which is applied raised to minus half. So this is the equation, raised to minus half is the equation for the junction capacitance. Now the junction capacitance will affect the switching characteristics of PN junction diode, as we'll see later how it affects the characteristics of PN junction diode when we are switching from the forward bias to reverse bias with respect to the minority charge carriers. This is the reverse biased PN junction diode